Hello friends, welcome to the session on data structure. In this session, we will be discussing about one more data structure called as a graph. You must have been seen that whenever we go from one place to another place, then most of the time what we do is that on our mobile phone, we make the use of the Google Maps. Now, Google Maps have implemented the various destinations on their software. And while implementing these destinations on their software, what they have used is just nothing but a graph. You must have been active on the social media. You must have been active on the Facebook. There you will find that there are large number of people and peoples are connected to each other. So whenever the peoples are connected to each other, in that case also, you will find that the social media makes the use of graph in order to represent every individual person. So friends, in this session we will discuss what we mean by graph, what are the different terms that are associated with the graph, and we will see what kind of operations can be performed on a graph. Friends, as you know that I am recording this session for PSS Central Institute of Vocational Education, and these sessions are recorded for the course Junior Software Developer. But the students from other courses, the students from other streams can also make an access to these sessions in order to learn the data structure. So friend, let us start the session and let us understand what we mean by graphs in the data structure. So as I said you that whenever we are dealing with the social media, just as LinkedIn, or whenever we deal with the social media Facebook, then you will find that every individual person can be represented by an identity called as a node. And then these individual persons are being linked with each other. A graph is a similar kind of a thing. You will find that a graph will consist of several nodes as shown in this window, and they are connected, the nodes are connected to each other by the edges. So what is graph? A graph is just nothing but a non-linear data structure. It is not a linear data structure like an array, but it is a non-linear data structure. And basically what it consists of, the graph consists of nodes and edges, where the nodes are normally circled and every node is being given certain number or name. And then the edges are being drawn in the form of lines. Sometimes there are arrows to the edges, sometimes we do not write the arrows to the edges. So nodes in the graph, they are being called as the vertices. So whenever we have certain node, say for example my node 0 is there in this graph, node 1 is there, then node 2 is there, then node 3 is there, and node 4 is there. So it is a graph that is consisting of 4 nodes. And these nodes can be called as the vertices, and these nodes are connected to each other by the edges. So these lines, they are being called as the edges, and these lines can be called as arcs also. So the nodes are connected to each other, or vertices are connected to each other by the edges or lines. So we can define a graph such as graph G is equal to the set of V comma E. So a graph G is basically a set and it consists of two elements. The first one is being called as a V and the another one is being called as a E. So where V is the set of the vertices and E is being called as the set of edges. So whenever we have a graph, then graph can be defined in the form of a set, and there are two elements in the set. The first one is being called as the V, which is actually the set of vertices, and the another one is being called as a E, where it is a set of edges. As far as this particular example of the graph is concerned, one can easily observe that the V is consisting of these vertices 0, then 1, 2, 3 and 4. So there are 5 vertices in this graph, and there are edges E, and these edges are written like this 0, 1. So we have edge from vertex 0 to 1, and therefore it is written as 0, 1. Then 1, 2, we have an edge from the vertex 1 to 2, then 2, 3, it means that we have the edge from the vertex 2 to 3, then 3, 4, we have the edge from the vertex 3 to 4, then 0, 4, then 1, 4, and then 1, 3. So in this way, we can write the set of edges. So in the set of edges, while writing the elements, what we do, we indicate it by the two numbers. The first is the vertex number from where the edge starts, and the second is the vertex number where the edge ends. So this is a way of writing the number of edges in the set E. Graphs, as I said you, is a very useful data structure because graphs can be used to solve many real life applications. For example, whenever we have some network such as telecommunication network, or sometimes we have a computer network, or sometimes we have a circuit network, then all such networks can be represented in the form of a graph. Graph, as I told you, can be used in the social media also. Whenever we have some social media or social network such as LinkedIn or Facebook or WhatsApp, then you will find that every person can be represented by a vertex or a node. So all social media, when they are implemented, they actually make the use of the graph data structure. Each node, you can say, is a structure, and it will consist of the information such as the identity of the person, the name of the person, the gender of the person, the address of the person. So whatever the information that is being associated with the person, that can be represented in the node, which is actually a vertex of a graph. Google Map, as I said, actually makes the use of the graph. So the cities are represented by the nodes, and whenever we want to find out the shortest distance between the two cities or between the two locations, then the locations are represented by the vertices, and with the help of the Google Map, we can determine the distance of the edges, and then we can find the shortest distance between the two locations or between the two cities. There is various terms that are being associated with the graph. Let us understand some terms that are associated with the graph. The first term is being called as a vertex. So as I said you, that every node in the graph is being called as a vertex. You will find that here we have a graph where the name of the vertex are written A, then B, then C, then D, then E, then F and G. So you can use either numbers 0, 1, 2, 3, 4, or you can use the characters such as A, B, C, D in order to represent the vertex. Then you will find that whenever we consider any two vertex in the graph, then they are sometimes connected with each other, and these connections are represented by the edges. So whenever I draw a line between A and B, then this is being called as an edge, and you will find that it is actually a path between the two vertices. So the path between the two vertices is being called as an edge, and these vertices are being called as the adjacent vertices. So whenever we have the two vertex and when they are connected to each other by some edge, then they are adjacent to each other. So there is a adjacency between the two vertices when they are connected to each other by some edge. So you will find that A and B are the adjacent vertices in this diagram. A and E are also adjacent vertices. A and D are also adjacent vertices, while we can say that the D and F are not adjacent vertices. There is another term that is being associated with the graph, and that is being called as a loop. So whenever we have a edge which is starting from the same vertex and it is ending at the same vertex, say for example from U to U, then that can be called as a loop. You will find that whenever we have a sequence of edges between the two vertices, then that sequence of edges between the two vertices is being called as a path. Whenever there is a path from any vertex to every other vertex of the graph, then such a graph is being called as a connected graph. So whenever it is possible that when we start from any vertex in the graph, and if we are able to reach to every other vertex in the graph, then such a graph is being called as a connected graph. There is also one term associated with the vertex, and it is being called as a degree of vertex. So degree of vertex will stand for the number of incident edges on the vertex. So we can count the number of edges, and depending upon the number of edges, it can be 1, 2 or 3. That is being called as a degree of the vertex. Sometimes you will find that the vertex do not have any edges connected, and such a vertex is being called as an isolated vertex. Or sometimes you will find that there is only one edge connected to the vertex, and such a vertex is being called as a pendant vertex. Also, it is possible that we can have a graph where the vertices are undirected, and therefore such graph can be called as an undirected graph. Many times you will find that the edges between the vertex have the arrow, and whenever the edges have a directional arrow, then such a graph is being called as a directed graph. And many times you will find that when we start in the graph from some vertex, and if we are able to visit all vertices and come back to the same vertex again, then such a graph can be called as a cyclic graph. So it depends upon the type of the application that you are using. You will find that you will require the different types of the graphs. Sometimes you will require undirected graph, sometimes you will require directed graph, and sometimes you will require the cyclic graph. It is possible that whenever we draw any graph structure on paper, and whenever we want to implement it, then that implementation can be done by two ways. Suppose we have been given a graph, and now I want to represent it in the memory. Then such a graph can be represented by using a matrix called as the adjacency matrix. For example, as shown in this window, suppose we have a graph where the vertex are A, B, then C, D and E, and you will find that there are edges connected between AB, then AE, then BE, then BC, then CD, then DE and EB. So you will find that if such graph is being given, then such graph can be represented by using the adjacency matrix. So on one side we will write all the vertices on the column side A, B, C, D, E. On the row side also we will write all the vertices A, B, C, D, E. And then you will find that if there is edge present between the two vertices, then that can be represented by 1. If the edge is not present between the two vertices, then that has to be represented by a number 0. Say for example, A to A there is no edge, therefore it is written as 0. From A to B there is an edge, therefore it is written as 1. From A to C there is no edge, therefore it is written as 0. From A to D also there is no edge, therefore it is written as 0. And from A to E there is an edge, and therefore it is written as 1. So in this way you will find that we can prepare the matrix, and such a matrix is being called adjacency matrix. So such matrix can be represented because it is a tabular form. Therefore such matrix can be represented by making the use of the two-dimensional array. It is also possible that whenever a graph is being given, then such a graph can be represented by making the use of the linked list. So linked representation is also possible. So whenever we have been given a linked list, then by making the use of the linked list we can represent a graph. Suppose this is a graph as shown in this window. Vertex A, B, C, D and E, these are the vertices, and there are certain edges between the vertices. Now if I want to represent it by the linked list, then I can draw the linked list as shown in this window. You will find that initially I will start with the node A, then I will go to the node B. From the node B there will be a pointer which will go to the node D, because there are edges present between A, B and D, and then finally there is no connection to the D, and therefore here I will mark it as a X. So whenever you start from the node A, you are able to go to the node B, and then you are able to go to the node D only. Whenever you start from the B then you can go to the A. So from B I can go to A, I can go to D, and then you will find that it is possible that from B you can go to C also, and therefore the link representation for the B will be from B to A, then A to D, and D to C. Similarly, whenever we think of the vertex C, then from C we can go to B, and then we can go to E. Whenever we think of the vertex D, then from D we can go to A, then to B, and then to E. And whenever we think of the vertex E, then we can go to D, and then we can go to C. So this is the way of representing the graph by the linked list. So whenever you want to represent any graph in the memory, then graph can be represented by either using the adjacency matrix. Adjacency matrix can be represented in the form of an array, two-dimensional array. And by making the use of the linked list also, you can represent the graph. So as I said, the adjacency matrix of the graph G is equal to V comma E with n vertices is n by n matrix, where Aij is equal to 1 if there is an edge from Vi to Vj, and Aij is equal to 0 if there is no edge. In the link representation, the graph can be represented by the adjacency list. It is possible that we can perform several operations on the graph. Say for example, if we want to visit each and every element of the graph, then that operation is being called as a traversing operation. Suppose we have been given a graph where there are vertices such as A, B, C, D, E, F, G, and H. And now if I want to visit each and every element of the graph, then it is possible, and that operation is being called as a traversing operation. It is possible that whenever some key element is given to you, then you can search whether the key element is present in the graph or not, and that is being called as a searching operation. Then whenever you have been given a graph and suppose you want to insert any new node into the graph, then adding of the new node is possible, and such operation is being called as the insertion operation. Whenever you have been given any graph and you want to remove any element from the graph, then that operation is being called as a deletion operation. And whenever we have been given a graph and suppose there is a need of merging of the two or more vertices together, then that operation in the graph is being called as the merging of the vertices operation. So these are the possible operations that can be performed on a graph. Also, whenever we have been given a graph and suppose we have certain set of vertices, and if you want to split any particular vertex in the graph, then the splitting operation is also possible. Means as far as the vertex of the graphs are concerned, we can merge them together and also we can split them, and all such operations can be performed. But as we know that whenever we want to perform any operation, then we need to write appropriate algorithm, and then only we can perform the operations on the graph. Also, whenever we have been given a graph and there are certain edges present where we want to make a contraction of edges, then this operation is also possible. So thank you friends for viewing the session. Hopefully you have understood the concept of graph, how the graph can be represented in memory, the different terms that are associated with the graph, and the operations that can be performed on a graph. Thank you all for viewing the session.